Hello everyone. Today I'm going to be discussing section 3 from chapter 7, Holt McDougal, using chemical formulas. Okay, so without further delay, I'm going to start talking about how to calculate formula mass, or what we call molar mass. So basically, the question that you're going to be solving in your SAT test is going to be as follows. Find molar mass for the following. So for instance, over here, we have to find the molar mass of barium nitrate, which is BaNO3 2. Now, how we do that is really simple, and it's actually one of the fun parts of stoichiometry. So basically, I'm going to use my black pen over here. So BaNO3 2. Over here, you can see, using the subscripts, we have 1 atom of barium, and we have 2 of nitrogen, and we have 6 oxygens. Okay, notice that we've multiplied 2 by 3 here to get the 6. And then what we do is that we just add the average atomic mass. So this is basically just the average atomic mass of barium, and this is that of nitrogen, and this is that of oxygen. Now, how do we get these numbers? I always teach my students to go to the periodic table. This is the easiest way to memorize that. And if you just open any periodic table, it's actually the big number. Okay, so you have 2 numbers. You have the small number and you have the big number. And notice that in different periodic tables, you can sometimes have the bigger number on the top and then the smaller one below it. But always, the smaller one always refers to the atomic number, which is the number of protons. And the bigger number is what we call the average atomic mass. So this is what we use in our stoichiometry calculations, this number, okay? The big number. Okay, so I'm going to need that for barium. So if I just go and look for barium over here, you're going to find that it's 137.327. Now only use, and this is actually from College Board, you're only going to need to use 2 digits after the decimal point. So here, the 7, we round the 2 to 3. So we have 137.33. And then, okay, and that's why we plugged in 137.33. Now we need that for nitrogen and oxygen. Nitrogen, okay, we go look for nitrogen. It's group 15, and it's 14.007. The 7 is going to round to 0, so that's 14.01. And that's why we plug in 14.01. Oxygen, same thing. 15.99.999. So it's 1599, and you're going to round that to 16. It's okay to round that to 16. Okay, so this is how we find our average atomic mass, and this is how we use it to find formula or molar mass. So we plug in these numbers, as you can see here. These are all plugged in. Notice that you're going to multiply by the number of atoms that you have. You have 1 barium, so that's multiplied. The average atomic number is multiplied by 1. For nitrogen, it should be multiplied by 2. For oxygen, multiplied by 6. And then we just add these numbers together. The final number, 261.35 gram per mole barium nitrate 2. What if the question just asks you about the formula mass of sodium, just an element, okay, and not a compound, just an element? So basically, all you have to do is that you just go to the periodic table and look for sodium. Okay, I'm going to flip my book to my periodic table. You can use the one in the back too. Sodium, group 1, and 22.989. The 9 is going to round the 8, so that's going to become 99, and that rounds up the 22 actually to 23. Okay, so it's 23 grams per mole. So basically, I want you to deal the average atomic number or average atomic mass as grams per mole. It's going to always have that unit, and that's going to help you a lot through calculations. Okay, so always think of this number having the unit of grams per mole of that element, okay? And when you add them all up, like what we did for barium nitrate, let's say, this is going to have that same unit, grams per mole. Okay, moving on to potassium chlorate, KClO3. As you can see, you have 1 potassium, 1 chlorine, 3 oxygens. As you can see, we plug in and we multiply, we add, and we get the molar mass of potassium chlorate. Okay, moving on to another topic in this section. As you can see, I've drawn 2 triangles, and this is how stoichiometry is easy when you look at it this way. Let's look at the first triangle. Okay, first triangle. Of course, you need to memorize these. So basically, this is a convergent factor, and this is where we start our stoichiometry formulas or rules. So basically, if you draw a triangle, and you know this method, my students are very, this is very obvious to them. And they have an idea about this. Remember, we studied this when we did density. We said density is equal to mass over volume. We used to put density over here and say that's mass over volume. Now, let me just remind you guys that this line over here in the triangle always means division. Okay, that's division. And this line over here is multiplication. Okay, same thing. So triangle 1, and I'm going to be referring to the contents and the elements of triangle 1 as triangle 1. Okay, so mass, molar mass, remember this is the molar mass that we just found, this number over here. So this is the molar mass. So if this number is plugged in here, and if you have the mass of, let's say, KClO3, you can find the number of moles, and vice versa. If you have moles and you have the molar mass, you can find mass. Now, I've derived these 3 formulas from this triangle. As you can see, if I want molar mass, it's mass divided by moles. If I want moles, it's mass divided by molar mass. If I want mass, it's molar mass times moles. And I'm going to give you, if you want to pause that, take a close look at that. Okay, let's solve a problem. Okay, let's solve a problem with that. Okay, given 2.5 moles of oxygen gas, O2. Now, notice that in your SAT, if they just say oxygen gas, I want you to make sure that you know that oxygen is a diatomic element, so we always refer to it as O2. It's not going to say 2.5 moles of O2. It's going to say oxygen gas. Now, I've just added that O2 in parentheses. I've added that because I want you to know that. But if they say nitrogen gas, then you have to take into consideration that you're doing your calculations according to N2. If they say hydrogen gas, according to H2. Chlorine gas, H2. Fluorine gas, then F2, okay? Etc. What is the unknown? The unknown is finding the mass of oxygen in grams. Okay, so let's go back to our triangle. So I have moles. 2.5. And the unknown is the mass. I want to find mass. Now, molar mass is always given because you can always find it out. Now, what is the molar mass of oxygen? The molar mass of oxygen is just 2 times 16, right? It's 16 from the periodic table. We found out that the molar mass is 2 times 16. That's grams per mole, that's its unit. Always put the units. That always helps you to know what you found and what you're still trying to find. And then you multiply it by the number of moles given. And then, as you can see easily, moles cancel with moles. Of course, This is moles O2, moles O2. So these two cancel. You just multiply these numbers and you get 80 grams of oxygen.